Imagine you are playing basketball and trying to shoot the ball into the hoop. Having mind of a physicist, you naturally got curious and started thinking about these questions. What is the path which the ball followed? Why did the ball follow this specific path? How high did the ball go? How far the hoop was from you? Or how far the ball traveled horizontally? When was the ball at its highest? How much time did the ball take to go in the hoop? This is not really difficult as you might think, and you don't have to remember anything extra. We are only going to use these two equations of motion which we already studied in the previous video. V equals to u plus at and s equals to ut plus half at squared. Imagine a bus which is not moving. You are inside it playing with a ball. You throw the ball up with some velocity. It gets to a certain height and returns in your hand. Let's see how the motion of the ball will look from outside the bus. Imagine that we are tracking the ball's motion on the top like this. Please bear with me and it will get clear soon as why we are doing this. Let's throw the ball and notice the tracking above. Imagine now that the bus is moving with constant velocity and we are just holding the ball. Watch what happens when you throw the ball up when the bus is moving with constant velocity. Did you notice? For you, who is inside the bus when it's moving, the ball is only going up and down. Let's do the animation again and notice the ball movement from inside the bus. And since this bus is an inertial frame of reference, we can apply Newton's law here in the bus. So only for vertically upward motion, and similarly we can apply Newton's law in the outside frame of reference too. You can treat the combined motion as the bus moving horizontally when seen from outside and the ball only moving vertically as seen from the bus. Both are valid analysis, and when combined you see the ball going on a parabolic path. So when you throw something with some initial velocity on an angle, we can do separate analysis for vertical and horizontal motion. Let's quickly run through the analysis now. Let's say you throw the item at an angle theta from the ground having velocity v. We can resolve the velocity in its horizontal and vertical parts. By convention, we can denote everything in horizontal direction with x and everything in vertical direction with y. What will be the value of vx and vy? Remember, in a proper vector denotation, the length of the vector denotes the magnitude and the tip denotes its direction. And since we are denoting directions with x and y, here we will only talk about magnitude. Let's shift vy here so that we get a right angle triangle. In this triangle, what will be the value of sine theta? It will be perpendicular upon hypotenuse. From this equation, let's get the value of vy. Similarly, what will be the value of cosine of theta? It will be base upon hypotenuse. And from this equation, let's get the value of Vx. But why are we doing this? To understand that, let's see how the particle's velocity is changing throughout the journey on this parabolic path. Here, splitting the velocity vector in Vx and Vy will make our analysis easier. Why? Because since gravity is pulling the particle downwards, it won't affect the horizontal part of the velocity. Let's see the same movement again, but with resolved velocities. You can see that the horizontal red component of the velocity remains constant, and only the vertical green component of the velocity is changing. Since the vertical component was going up, it first reduces to 0 and then goes downwards because the gravitational acceleration is downwards. Now that we understand the concepts, we can work through the math very easily. So, first things first, why this path is a parabola? To answer that, we will have to get the relation between the horizontal range and vertical height. So first, let's write the equation of horizontal range. Since the horizontal velocity is constant, the range will simply be horizontal velocity multiplied by time of flight. And since vertical movement is an accelerated motion, the equation for height will be initial velocity, in this case Vy, which is v sine theta, times the time, plus half time acceleration multiplied by time squared. Now, since the particle is moving upward and the gravitational acceleration is acting downwards, the value of acceleration will be negative g. From these two equations, if we eliminate time, we will get the relation between range r and height h. So basically, get the value of t from one equation and put it in the other. Rearranging this equation just a little bit gives us this. In this equation, notice that these terms do not change while the particle is moving on the parabolic path. Now we can rewrite this equation where a and b are constants. This is a standard form of an equation of a parabola, and this tells us that the path will be a parabola. Let's see what will be the time of maximum height, meaning after throwing the projectile, how long will it take to get from ground to here at the very top of its path. As you may have noticed, at the peak, the vertical velocity becomes zero. And from equations of motion, we know that final velocity v equals to initial velocity u plus acceleration a multiplied by time t. In our case, final velocity is 0. Initial velocity is v sine theta. Acceleration is gravitational acceleration g acting opposite to the direction of motion, so negative. And the time is our time of maximum height. And this gives us the value of time of maximum or peak height. To get the maximum height, we put this time in the equation for height. We can then simplify this equation and get the maximum height of the projectile. Since the acceleration due to gravity is uniform, the upward and downward motion of the projectile are symmetric. So the time projectile takes to get to the peak height from ground will be the same as it takes to come back to the ground from the peak height. Hence the time of flight equals to 2 times the time of maximum height. And now the last thing, the horizontal range of the flight. For that, we can simply put the time of flight in the equation for range. Simplifying this will give us horizontal range of the flight. And these are the answers to 4 questions we asked in the beginning. I will see you in one of these 2 videos. The left one is highly recommended to watch. Thanks for watching and subscribe for more.